Hi everyone, here we are in chapter 9. It's called Differential Equations. So it was nice to have chapter 8 right before the second exam. Pretty slow chapter, and it was nice to just have the videos for that. Because there wasn't much really in any of the four sections. Well, we're going to make up for that in Chapter 9. Chapter 9, Differential Equations, pretty heavy topic. Here in 9.1, we're just going to introduce them. It takes a little time just to wrap your head around what a differential equation even is and get comfortable with it. Eventually, we're going to solve them. That's what we'll do in 9.2 and 9.3. Also, just kind of give you an overall idea of how we're going to go about this chapter. In 9.2 and 9.3, there are applications, of course, right? Every section we do usually has some applications. But with differential equations, I find it's more helpful to just go through the techniques that we'll see in 9.2 and 9.3 and avoid the applications, but then we're going to come back and almost like treat that as one section all on its own. So I call it 9 plus. But really we're just going back and we're doing the applications that would have been a part of 9.2 and 9.3. We're just kind of doing them all at once because, again, we just want to spend time getting our heads around what these things even are and then how do we solve them. So let's get started with that. Also, you might notice I got some shadows here, kind of working in the afternoon sun. But this is my time to film, to shoot my video, so hopefully it'll work out. All right, so 9.1 is basic concepts. It's our introduction, and I've got the definition of a differential equation right there. So it's maybe you expect just by the name that it is an equation, which we will solve, and it involves derivatives. So it's an equation which contains an unknown function and its derivatives. Let me give you an example. So here we go. Here's a pretty simple one over here at the left. X times y prime equals 3 times y. Okay, so we're thinking the unknown function is y, and then we've also got a derivative of y. Now we also have the variable x in there as well. We're still thinking of y as a function of x. And so here we go. And you're like, wow, that seems kind of strange. You know, I've got y times 3 and x times the derivative of y. Like, weird. The idea is we're going to develop, not in this section, but in later sections, we're going to develop techniques to figure out what function y would make this thing true. What function y would I plug in here, and then I would take the derivative of y and plug it in there, and it would make a true statement. We're not going to do that. We're not going to solve these in 9.1, just getting introduced to what they are. Okay, so that's one example, one style. Here's another one. And kind of got some shadows there. Interesting. Okay. Now this one's got a little bit more going on, right? So quantity 1 plus 3x to the third y squared times y prime equals 2 minus 3x squared y to the third. Again, you know, there's some unknown function y. Okay. Let's define a solution to a differential equation. So it turns out that there's two different forms that solutions can take, and I'll just give you the overview for the moment. It might be a function y, which makes the differential equation true. Could I figure out, or at least be told, what a function y is that I could plug in, right? Plug in there, plug into its derivative, make a true statement. Or there's this other way we can think of a solution, an equation, not a function this time, but an equation whose implicit derivative leads to the differential equation. Actually, that's going to be the case here. So it turns out there was another equation where if you take the implicit derivative, it would lead you to this statement. So it's a totally different way of thinking of a solution, right? What other equation whose implicit derivative would eventually wind up with that? Okay, so we're going to look at both of these in greater detail as this section develops. I want to spend a moment and just look at this one a little bit further. What happens in this section, 9.1, we're not going to develop the ways to solve these differential equations. Instead, and it's going to feel kind of awkward, instead, they're going to tell us what the solution is, and then we just have to verify that it's true. Okay, so we're really taking our time getting used to what a differential equation is before we're ready to begin solving them. So it's sometimes it can even be like so simple that it ends up being kind of confusing until we start really solving them. But this is always the way these things are introduced. Okay, so without further ado, I'm just going to tell you what function y could you plug in to solve this. Okay, here it is. It's actually pretty simple. This particular differential equation is solved by y equals x to the third. All right, so let's confirm that y equals x to the third really does solve this. So kind of trying to cover up part of what's over here. Okay, so y equals x to the third, so that means its derivative y prime is 3x squared, right? So we're going to take both of these and we're going to plug them in where we see y and where we see y prime. And it's going to lead to a true statement. Okay. Again, this is like so simple, it might be confusing. All right, I'm going to take y prime, plug it in. So I got x times y prime equals 3 times y. Okay, plug in the derivative, plug in the original. Do I get a true statement? Are these really equal to each other? Are those really equal to each other? Yeah, they sure are, right? They're both 3x to the third. And so that confirms that this is a solution to that differential equation. Now you might, again, you're still like, this is so bizarre. So it turns out way back a few hundred years ago when calculus was first being developed, actually the motivation for calculus was to solve differential equations. Now this one maybe not so much. We're going to see the applications at the very end of this chapter. But it turns out people, really intelligent people at that time, they were thinking about rates of change, right, derivatives, and they were able to come up with differential equations, but they had no idea how to solve them, because they didn't know that a rate of change was like the slope of a tangent line, and they didn't know about antiderivatives, obviously. So they came up with equations that were similar to this, actually probably a lot of them more complicated than this one. But they had no means to figure out what that function y was, and so that eventually inspired the development of calculus. And maybe it goes without saying now, but differential equations is probably the most useful, most applicable thing when it comes to business and economics and studying physics and all those things too, chemistry. I mean, they really, the calculus that you see in those industries is solving differential equations primarily. Now they do all the other stuff too, but really the big part of it is solving differential equations. Okay, so I like to compare this intro, really in this entire section 9.1, to like your first day in an algebra class. So we're being introduced to this sort of strange equation. We're not even talking about how to solve them. Okay, so think back to like your first day in algebra. And what happened? So that's what I've got here on the side. And again, apologize for the shadows, but I think you can read what I'm doing. So I say at the top, compare to the first day of algebra. So what happened? So we got shown equations like this, right? And now there was like an x involved, and we're like, what is that all about? What is this x? That's so strange. And they said, oh man, that can represent any number. And actually the point of this equation is to solve it, and we're going to figure out what number needs to go there to give us a true statement, right? So 2x plus 1 equals 13. Now at this point, on our first day in algebra, we have no idea how to solve an equation, right? We don't know to subtract 1 from both sides and then divide by 2. Like they haven't gotten that far yet. So what did we do in the first day of algebra? They just told us the answer, and it was just our job to confirm that. So we took, x equals 6, and they said, okay, so we're going to tell you an x value, you plug it in, and you confirm that it really does work out. So we take the 6, we plug it in, and oh my gosh, that's 12. Oh my gosh, 12 plus, it worked. That must be the solution, right? So then maybe in the second day of algebra, then they start telling us about like doing the same thing to both sides and how to solve. But not on the first day of algebra, and not on the first day of differential equations. So all we're doing here, we're giving you the equation, we're telling you what the answer is. It's simply our job to plug it all in and confirm we get a true statement. We're going to do a little bit more than that, I guess, but that's really the gist of this first section. Okay, let's continue this discussion. So maybe you've thought about this and you're like, hey, is this the only solution? Could we make like maybe small adjustments to y equals x to the third and still get a true statement when we plug in? If you were thinking that, wow, you are really onto something. So here's where I will continue. What about y equals 2 times x to the third? So kind of same idea. We'll take the derivative. Well, I might as well show you this too. So 2x to the third, we'll take the derivative and we'll plug it in. X times y prime equals 3 times y. Does it still give a true statement? Oh my gosh, it does. Now this time it happens to be 6x to the third. But I guess we could say this is another solution to that same differential equation. There's a second solution. And once you see that, you're like, oh wow, I guess you could put any number here you like, right? Because it's just gonna kind of carry down in the derivative, and it's always gonna work out. I can put negative numbers here, whatever I like. And so here's what we end up calling the general solution in this case. The general solution to this differential equation is y equals capital C x to the third, and the capital C is the same capital C that we've known for some time now. It's an arbitrary constant. It's an arbitrary constant that would come out when you do an integral. Turns out we're going to use a lot of integration to solve differential equations. And so that's where it would appear here. Any number C you can put there in front of x to the third, and you will get that differential equation to work out. And I guess here I'm like verifying it's true for the general solution. If y equals capital C x to the third, then there's the derivative, 3c x squared, and I'm plugging in y prime, I'm plugging in y again, and I'm confirming, yep, whatever value of c, you're going to get 3c x to the third on both sides. And we've like verified that general solution now for any real number c. Okay, let's stop this video here. We are going to look at some more in a moment.